All right, here we want to prove this trig identity, and I noticed I have a little mark on there. And so what I'm going to do is, again, in typical fashion, I'm going to start with the kind of the harder side over here and try to get it to equal this. All right, right away when I see this, I'm like, oh, I can use something. All right, so we have the sum and difference formulas, and so cosine is kind of coupled together. So these stay together, and these guys stay together. Right, and then with cosine, the sign changes, so that's actually going to turn to be a plus. All right, and then my denominator is just this guy right there. And at this point, I'm kind of stuck, or it's kind of like I can't factor out to do anything, so it's like, what can I do from here? Remember in algebra, if you're dividing by, say, a monomial, like say, maybe that's a 6 and this is a 3. You can divide each piece by 3, that is legal, and get, what is that, x squared plus 2x. Kind of like taking 340, that's not a good example, sorry. Taking 363 divided by 3, you can divide each piece by 3, and that will work. If you're dividing by binomial, you can't do that. You're going to have to do long division. So if you have like x squared plus 8x and plus 3, and you want to divide by, say, x plus 2, this is not a monomial, so you're going to have to go ahead and do long division. No different than if I gave you something like this and you had like 13. Again, that's not a single chunk. It's not a monomial, so you'd have to do long division. And so basically what I can do here is I can go backwards, all right? So I can go back and write the problem before I added together. So I have my common denominator, but I can divide each piece by that. So I can divide this piece by that and this piece by that. So it's kind of like the step it was before you added. And again, the only reason I can do that is because I have a monomial, so I can kind of divide each piece by that. All right, so then what do I get? Well, these are factors within this problem. I can't look on this side. This side is, these are adding problems. This is add-ins. These are terms. So I can't cancel within the problem, but I cancel within the fraction. So within this fraction, this goes in there once, that goes in there once, and that cancels. So I get sine of beta over cosine of beta. And then on the other side, again, these are factors just within this problem, not when I start comparing it to this, only within this. And so you can see that those go in there once. And so I get cosine of alpha, sine of alpha. And then if I look at that, cosine divided by sine is cotangent, and sine divided by cosine is tangent. And so then I get what I wanted to prove. So if you look at this side, let me just erase my chemical from before. But if you look, this is what we were going to prove. Okay, so I need to get my pen again, obviously. So if I get my pen again, this guy is what? Cotangent of alpha, and this guy is tangent of beta. And again, that was what I was trying to prove, and so I did that.